Okay, I'm going to be honest. The first part of this lesson, binomial theorem, not the most important thing to remember from this unit on probability. But there are a couple of takeaways that I just want to point out to you and make sure that you caught from the previous video. So first of all, when we're dealing with the binomial theorem, and I'm going to be doing number 6 on your notes, there are a couple of shortcuts that we can do with this, right? And so they used Pascal's triangle to kind of show you what those coefficients could look like, and that's one way to do it. But another way to find those coefficients is by using combinations. And so you'll notice that one of the shortcuts is your combination is constantly going down. So if our exponent is 8, then we're choosing from 8, starting with 0. Then the next term will be 8, choosing 1, 8 choosing 2, 8 choosing 3, 8 choosing 4, 8 choosing 5, and so on and so forth. Right, so that's pattern number 1. Then there's pattern number 2, which is you're basically taking this first term in your binomial. All of these will be binomials. That's why it's called the binomial theorem. So the first term in the binomial in this case is k. And we're going to start by raising it to the 8th power, and then we're going to go down by 1 each time. So the first term has k to the 8th, k to the 7th, k to the 6th, k to the 5th, and so on and so forth, right? And then the last shortcut here is we're taking that second term in the binomial. In this case, it's just a 2. And we start by raising it to the 0 power, and then each term, we're raising that by 1. So 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, and so on and so forth. So if I were going to calculate this, first I'm going to start by changing all of these combinations. So 8 choose 0, 8 choose 1. We're just going to take care of all those. So 8 choose 0 is 1. 8 choose 1 is 8. 8 choose 2 is 28. 8 choose 3 is 56. 8 choose 4 is 70. I should probably just pause the video and fill these in real fast. All right, and then also remember that each of those coefficients now that we have that came from those combinations would have been the coefficients of Pascal's triangle if you were to do Pascal's triangle down to the 8th row. And again, where the 8 is coming from is whatever your exponent is on your binomial. So we took care of that. But those aren't our final coefficients, because when we raise 2 to powers, that's going to give us numbers 2, and we're going to multiply that by the coefficient that we got when we did our combination. So for example, 2 to the 0 power is 1. So really our first term is going to be 1 times 1, which is 1, k to the 8th power. I'm going to erase this because we're going to run out of room here. Here we have 2 to the 1st power, 2, times the 8. So we're going to have our second term, 16, k to the 7th. Here we have 2 to the 2nd power, 4, times 28. And that's going to be 112, k to the 6th power. 2 to the 3rd is 8, times 56. Get 448, k to the 5th power. So our numbers are not going to match Pascal's triangle anymore at this point because of the 2's, because we're multiplying by 2 to whatever power as we go. But you'll notice that your k's are still going down, the degree is going down by 1 each time, and that pattern will continue. So here we have 2 to the 4th, 16, times 70, 1,120. We're on k to the 4th. Forgot my plus sign. Here we have 2 to the 5th, 32, times 56 is 1,792, k to the 3rd. Hold on. I messed this up somewhere. Oh no, we're good, we're good. All right. It's just that the next term is also 1,792 k squared. When we take 2 to the 6th times 28, just messing myself up here because I pre-wrote these to make this a little bit faster. Here we have 2 to the 7th times 8, that's 1,024. And then lastly, we have 2 to the 8th power, which is 256. So this would be our answer if we had expanded k plus 2 to the 8th power. So again, that would have been k plus 2 times k plus 2. Then we would have taken that answer, multiplied by k plus 2. Taken that answer, multiplied by k plus 2. That would have been a lot longer process than using this little shortcut. But again, binomial theorem, not the most important thing from this unit. Now let's talk a little bit about some binomial probability that you did in the second half of this lesson. So binomial probability we use when you really only have 2 different outcomes possible, success or failure, winning or losing. And you can calculate both of those probabilities pretty easily because they have to add up to 1. So obviously you have to know one of the probabilities before you can use binomial probability here. But number 7 from your notes, we're talking about a game of chance, and it says the probability of winning is 30%. 15 games are played, so if we're using that formula that was given to you, that means N is 15. That's how many trials are being run. The probability of winning, we just said, was 30%, so I'm going to write that as 0.3 or 3/10, either one is fine. And so if our probability of winning is 0.3, that means our probability of losing is 0.7. Just take 1 minus whatever the probability of success is. And then we want to win 6 times. So R equals 6. Running out of room on my tiny little board here. So then when we do our binomial probability formula, it would be set up like this. 15, choose 6, because we want to win 6 times. To win 6 times, the probability is 0.3 to the 6th power. But if we want to win 6 times, that means we want to lose the rest of the times. So we're going to lose 9 times. We're doing 15 trials. We want to win 6 of them. That means we want to lose 9 of them. So we're also going to multiply by 0.7 to the 9th power. So let me type that into my calculator real fast. 15, choose 6 times 0.3 to the 6th times 0.7 to the 9th. And my answer is about 0.1472 or 14.72%. Number 8 seems a little bit more confusing because it seems like there are 3 different things going on. We've got a traffic light, and the traffic light can be red, yellow, or green. Red is 20 seconds, yellow is 4 seconds, green is 36 seconds. Find the probability that of the next 12 cars, exactly 4 will be stopped by a red light. So N is 12 because we're looking at 12 cars. So that's the number of trials. And then the probability of winning, what we want to see is we want to see the number of cars stopped by a red light. So that's what we want to happen, red light. And so it says that the stoplight is red for 20 seconds of the 60 seconds. So our probability of it being a red light would be 20 out of 60. If you add up all 3 of those numbers together, we get 60. So 20 out of 60 would be our probability of winning. That reduces to 1/3. And if 1/3 is our probability of success, then that means our probability of failure is 2/3. And then R, in this case, we want 4 cars to be stopped by a red light out of the 12. So 4 out of 12 cars we want to be stopped at a red light. So let's put it all together. 12, choose 4. Our probability of winning is 1/3. We want that to happen 4 times. We want them to be stopped by a red light 4 times, 4 cars of the 12. And then that means the other 8 cars of the 12, we do not want to be at a red light. So this is how we would set it up. I'm going to give you a second to type that into your calculator to see if you get the right answer. So pause the video. Your answer should be 0.2384-ish or 23.84% on number 8. The last problem I'm going to do is number 10. Number 10 does work a little bit differently because it's an at most or an at least problem. This particular one is at most. So we're randomly choosing a day of the week 6 times, so 6 trials. N is 6. What's the probability of choosing a Tuesday or Thursday? So Tuesday or Thursday out of 7 days of the week. So that's 2 days of the week out of the 7 days of the week that we want. So to get a Tuesday or Thursday would be a 2/7, which means to get anything other than a Tuesday or Thursday would be 5/7. So now we know our N, our P, and our Q. The tricky part is R on this one because it says we want the probability of choosing a Tuesday or Thursday at most 3 times. So R is a little different in this one. We don't want it to happen exactly 3 times. It could, but we want at most 3 times. So that means R could be 3. It could be 2, it could be 1, or it could be 0. So 3, 2, 1, 0. We want it to happen at most 3 times. So it could happen 3 times, 2 times, 1 time, or 0 times. So what we need to do on this particular problem is we need to set up 4 different formulas. 1 for 3, 1 for when R is 2, 1 for when R is 1, and 1 for when R is 0. Let me set up the first one for you. So if R is 3, we'll just go in order here. We would have 6 choose 3 times 2/7 to the 3rd times 5/7 to the 3rd. And then we're going to calculate that probability. We'll save that till the end. Let me do one more of those. So when R is 2, we would have 6 choose 2, 2/7 to the 2nd power, which means 5/7 would be to the 4th power. And then we'll calculate that probability. Go ahead, pause the video, write down your next 2 that you think it would be, and then go ahead and fill in the answers. All right, no spoilers if you're not done yet. Keep pausing the video if you're not done, but here are the answers we should have gotten. So we've got 4 different probabilities, one for choosing a Tuesday or Thursday 3 times, 2 times, 1 for 1 time, 1 for no times. So we've got all these different probabilities. To find our total probability then is we just add those individual ones together. And when we do that, we get 0.9402, or you've got about a 94% chance of getting that then.